Hello everyone, good afternoon. My name is Hamid. I am a graduate student of computer science at UC Riverside. My project is a Taverna workflow engine for detecting novel microRNAs, and my mentors are Jihun Kim and Dr. Oho Mashado. So let me begin with the tools I used for this project. miRDeep is a Perl-based tool for detecting novel microRNAs. And we selected miRDeep because it's the most widely used tool for this purpose. Taverna is a workflow management system. I will talk about it in next slide in more details. So our main goal was to design a new workflow for detecting novel microRNAs based on miRDeep method in Taverna environment. And we wanted the workflow to be more flexible and faster than regular miRDeep. We also wanted the workflow to handle multiple samples at the same time. So this is the current pipeline we use in iDASH for analyzing and detecting microRNAs. So it has a lot of details. We don't need them. We have three main steps: pre-processing, single sample processing, and multiple sample processing. So after some pre-processing over RNA-seq data, each RNA-seq sample is processed individually in the single sample processing step. And the result of several single sampling processing outputs are combined in the last step, multiple sample processing, and the final prediction is made. But everything is fine about this pipeline. We just want to try different tools for some particular steps of this pipeline easily and rapidly. Also, we would like to combine the single sample processing step and multiple sample processing step. We don't want to process every sample individually and then combine the final results. We want to process them at the same time in parallel. So we decided to design a new workflow for that. And what's a workflow for at the beginning? A workflow is a set of activities or processes and data flow among these processes. So when we use a workflow and design a workflow in a workflow management system, we don't need to be worried about the details of implementation. We just select or desired tools from a pool of tools or services, put them in our workflow, and define the data flow among these processes. So we selected Taverna because it's widely used in bioinformatics projects, and this is the main graphical interface of Taverna. We have a window here. We can design our workflow and data flow among our steps here in this window. In this window, we see the available tools and services, including online and local services. And here we can see more details about our steps and paths in the workflow. So this is the workflow I designed for detecting novel microRNAs based on miRDeep in Taverna environment. Again, we don't need the details. I think you cannot even read the tags. I magnified a part of it to show you how does it look like, but it consists of several parts, several components. We have some input parameters here. The sky blue boxes are input parameters. We have some constant values here. The darker blue boxes are constant values. And these purple boxes are input and output steps. For example, writing to a file or reading from a file. And the main parts of the miRDeep algorithm, the computational demanding parts, are these orange boxes. So when we feed the pipeline, with the workflow with our RNA-seq samples and input parameters, they go through all of these steps, and finally they reach here, and here the workflow predicts some novel microRNAs and writes them to a file. So we believe that this workflow is more flexible than regular miRDeep. For example, for this step, we need to map short reads against a reference genome. So the default tool which is used in miRDeep is BLAST. But we also implemented another mapper called BWA, and we put a conditional branch over these two boxes, and user can easily select among them. By just typing BLAST or BWA, he can change the mapper without affecting the other parts of the workflow. So it's more flexible than regular miRDeep. Also, it's faster. I took a snapshot when it was running, and as you can see, we have some parallel steps in the workflow. And these boxes next to each other are executed in parallel. So we have a speed up here. Also, every step can handle multiple samples in parallel at the same time. Actually, every of these steps, each of these steps create multiple threads of the same code and run these threads using the available samples. So we have two levels of parallelization in this workflow. So I just showed you a new workflow for detecting novel microRNAs based on miRDeep tool implemented in Taverna workflow management system. It's faster and more flexible than regular miRDeep. It can handle multiple samples in parallel at the same time. Also, it's actually a part of a bigger project called iDASH Cloud, and this was the first workflow implemented in Taverna, and it was kind of pilot project for this iDASH Cloud architecture. We wanted to see can we use Taverna for this purpose or not. So we are going to design a lot of more workflows, including a de novo assembly workflow in Taverna. Also, we are working on a new method for detecting novel microRNAs, which we believe that will be more accurate. I would like to use this opportunity to thank my mentors, Jihoon Kim and Dr. Oh Machado. Also, I would like to thank Nate for his help during the summer and in Cal 82, which was our home, and iDASH and DBMI, which prepared us this opportunity to do research on these interesting topics, and NIH, which funded this project. Thank you very much.